Okay, let's dive right into this explainer by tackling an absolute relatable data nightmare. Imagine you're building a system that takes in massive amounts of user input. But honestly, it's a complete messy disaster. People are impatiently clicking submit buttons twice, forms are glitching and sending multiple times, and your pristine database is rapidly filling up with absolute junk. It is literally a programmer's worst nightmare. So how do you handle that efficiently without your system grinding to a halt? Well, today we're looking at a specific abstract data type designed purposely to handle this exact problem, the set. We're going to unpack exactly how it works and why it might just become your absolute favorite tool. To put this into a little bit of concrete perspective, think about a scenario where a teacher is recording student club choices. Accidents happen in data entry, right? So some names get repeated in the input list. You end up with this messy list that looks like Anna, Ben, Anna, Kara, and Ben. Now, rather than writing a clunky, incredibly slow program that repeatedly scans a massive array from start to finish just to find and delete those duplicates, we're going to introduce a specialized, super-powered filter designed for exactly this job. It's going to save you time, memory, and quite frankly, a massive headache. All right, here's our roadmap for this explainer. 1. Meet the set. 2. The core set operations. 3. Sets in action using Python. 4. Subsets and supersets. 5. Sets versus arrays. And finally, 6. Avoiding common mistakes. Let's jump right in. Section 1, Meet the set. Let's get a clear understanding of what actually makes this abstract data type so incredibly unique. A set, by definition, is an abstract data type that stores distinct values with absolutely no duplicates allowed, period. Honestly, think of a set as a strict, completely uncompromising club bouncer checking a VIP guest list. That bouncer is really only there to instantly verify membership. They are asking one simple question: is this person on the list? And they will strictly ignore anyone trying to get into the club twice. They don't care if you try to sneak in wearing a fake mustache. If your name was already checked, you're ignored. What about the order they arrived in? The bouncer absolutely does not care. You could be first in line or 50th. It's entirely about presence and uniqueness. If you're in, you're in. Now, what's really interesting here is how these characteristics completely shift our programming mindset. In computer science, we are so used to arrays, right? Where we care deeply about the sequence, the first item or the third item. Sets demand a completely different approach. They are inherently unordered. They strictly enforce unique elements only, instantly collapsing any duplicates into a single instance. And because of this beautifully rigid structure, they offer ridiculously fast membership checking. Plus, they're purposely designed for mathematical operations like union, intersection, and difference. You aren't navigating a line of items anymore. You are querying a collective pool of unique data. Section 2, the core set operations. Let's see how this builds into some really powerful mathematical comparisons. When we look at the core math, it brilliantly illustrates exactly how sets handle data. First, we have union, represented by that U-shaped symbol. Think of this as just throwing everything into one big pot. If set A has 1, 2, 3, and set B has 3, 4, 5, the union combines them all into 1, 2, 3, 4, 5. Notice the 3 only appears once. The set automatically filtered the duplicate. Next up is intersection, the upside-down U. This asks what elements are exclusively common to both groups. For those exact same sets, the result is just the number 3, because it's the only shared value. Finally, difference, represented by the minus sign. A minus B means we take elements in A and strictly remove anything that is also found in B. That leaves us with just 1 and 2. It's an incredibly clean, efficient way to combine elements, find common ground, or subtract differences with zero duplication cluttering up your results. Section 3, Sets in Action, Python. The crucial point here is taking those abstract math concepts and translating them into practical code. In Python, the implementation is beautifully straightforward and remarkably powerful. Say we have a set of numbers. To check for membership, you literally just write if for in numbers. The in keyword does all the heavy lifting. And here's a fantastic, somewhat surprising fact about what's happening under the hood. This is lightning fast. While an array forces the computer to scan every single item one by one to find the number 4, a Python set uses a structure called a hash table, which lets it verify membership almost instantly, no matter how massive the set gets. That is its true superpower. To insert a value, you just use numbers.add8, and to delete, numbers.remove2.
Because sets inherently maintain unique values, if you try to add a number that already exists, the system just silently ignores it. This is exactly why it's so perfect for our earlier student club scenario. You just keep adding names, and the set handles the dirty work of filtering out the repetitions for you.
Section 4. Subsets and supersets. Beyond just manipulating individual items, we also need to evaluate relationships between entire sets. This brings us to subsets and supersets. Set A is a subset of set B if every single element in A is also residing in B. Conversely, B is a superset of A if it contains absolutely everything that's in A plus potentially more. For example, the small set containing just 2 and 4 is a subset of the larger set containing 2, 4, 6, and 8. These whole collection comparisons, they are incredibly useful in everyday programming. Think about checking real-world rules like digital user permissions. Does this user's specific set of access rights contain the subset of rights needed to open this highly classified file? Or maybe verifying if a college student has completed the required subset of class prerequisites to graduate. Sets handle these kinds of sweeping checks completely effortlessly.
Section 5. Sets versus arrays. Now we arrive at the ultimate showdown, comparing our superpowered filter against the traditional array. This direct contrast highlights a fundamental design decision you have to make as a programmer. Let's break it down. Sets have an unordered focus and strictly forbid duplicates. They are highly suitable for fast membership checks, but index access is absolutely not their purpose. On the flip side, arrays and lists are all about ordered sequence. Duplicates are almost always allowed. But to find something, you might be forced into a slow linear search, checking position by position. Arrays are, however, great for direct, position-based index access. So, the golden rule here is this. Choose a set when strict uniqueness and rapid membership checking matter most, and stick to an array when you specifically need ordered storage to pull items out by their exact index position.
Section 6. Avoiding common mistakes. Before we wrap up, I want to share some crucial pro tips to save you from future coding headaches.
You know, it is very easy to fall into old array-based habits when you first start using this ADT. The most common mistake? Assuming sets keep elements in a meaningful order. They absolutely do not. Never expect a value to appear multiple times, no matter how many times you mistakenly added it. And please, never fall into the trap of attempting to use indexed access. If you write code trying to pull item 3 from a set, your program isn't just going to give you a warning, it is going to spectacularly crash. The set literally has no concept of a third item. They are completely different tools from arrays. Oh, and make sure you really memorize the mathematical differences. Union combines everything. Intersection strictly finds shared items, and difference subtracts. To bring this all together, consider this classic scenario. A music app needs to store the genres a user likes, say rock, jazz, and hip-hop. Is a set a suitable abstract data type for this task? Well, ask yourself, does the sequential order of those genres actually matter to the application? Or are strict uniqueness and fast membership testing, like instantly knowing, hey, does this user like jazz, the real goals here? Understanding that distinction is key. But think bigger for a second. How do you think Spotify instantly calculates the shared music tastes between you and millions of other users to generate your customized Discover Weekly playlists? Let me give you a hint. They certainly aren't using slow arrays to find those massive intersections. Thanks for hanging out with me for this explainer, and I'll catch you on the next one.